use one server, and the other one you can use different servers. Speaking about the processing, we have two important topics because we can process your information in batch. That means that you are processing your information in large amounts of data that are going to have low latency response. For example, you can submit one job and you can expect the response maybe 2 hours before or 3 hours later. That is the batch processing. But if you have processed your information in the same moment that the information arrives to your system, you are going to speak about transactional processing workloads. In big data, those concepts are very important because define what tools are you going to use to resolve one specific problem. Remember, batch processing or transactional processing. It's very important concept. And the other enabler we are going to speak about is cloud computing. You spoke about the cloud computing in the last session. So today we have several vendors for big data. Amazon, for example, Microsoft with Azure, for example, Google Cloud. Are vendors that provide us with systems, predefined systems that we can use to implement our big data solutions. Okay. In this moment, this slide is very important for me because defines how you can implement one project in a layered way. It's more or less related with the previous one that we saw about the stages, but it's not conceptual, but here we have maybe a logical architecture about what conforms one big data project. We have a data source layer, data acquisition layer, storage layer, processing layer, analysis layer, visualization layer, and utilization layer. Note that all of these are in a vertical way, but we have also horizontal layers that are related with all of these one. Yes. And we have a management layer, security layer, governance layer, and we are going to go deeper on all of that each one in the next in the next slides. The first one that I want to speak about is the storage layer. Note that we have different mechanisms here. We have the distributed file system that we defined previously. The distributed file system is a way to store information in different nodes. You can have, for example, one data set and you send information to the data to the distributed file system. Automatically, the data set spreads out into the different nodes. You define and configure that. You don't do that manually. It's just configuration. You only just say to the system that you need to storage one file and information, choose which node use to store as information. The other one is NoSQL databases. The NoSQL databases, we spoke about that. It's like a way to storage information coming from different data sources. And you can here query information different from this. You have different possibilities to storage information here. And also we have another mechanism is called in-memory storage device. Because today we can use from the market information, databases that stores information in memory. Because the processing of the information in an in-memory database is faster because it's not, the information does not go to the disk to give you a result. If all the information is processed in memory. One important fact here within memory databases is that expensive. You want to implement in memory databases, you are going to increase your budget for the project. Different, for example, from distributed file system, because distributed file system is so cheaper for the company. You can use one cloud, for example, or one simple server to implement the distributed file system. It's cheaper use distributed file system that use in memory databases. But also we have here two mechanisms that are important when we are speaking about the storage layer. Is the compression engine. The compression engine is the mechanism you use to save information into the disk in a compressed way. And are different engines to try to do that. And also the serialization engine. Because, for example, if you are dealing with JSON formats, the information is moving from one system to the other in a binary, in memory way. Yes, but if you have to storage, you have to make the serialization of that file. And the serialization engine is the one that helps us to do that task. Here we have different layers in action. I have included this slide because it's important to see how one batch processing layer interacts with all of different layers. In this case, for example, it says that we have data coming from different sources. Here we have semi-structured data and unstructured data, and we have different data acquisition. And in data acquisition layer, we have different engines. We have here the relational and data acquisition engine. Also, we have even data transfer engine. Even data transfer engine, relational transfer engine are different mechanisms that we use to bring information from different sources, from the data source layer. The event data transfer engine help us to process the information that we process in the same moment. If we, for example, are speaking about information coming from one sensor, we are going to use one event data processing. But if we are using, for example, information coming from the relational database, we are going to use the relational data transfer engine. There are different sorts of transfer engines that we can use to move the information from the data source layer to the storage layer. Because the first step that we need to make is bring information from the source layer to our system, our storage layer. And we use different mechanisms for that. And then we have the source, the transfer engines, and the storage layers. So we are here having the one ETL process. Yes. Also, in the upper layer we have the processing layer, and we have the graph processing engine. The graph processing engine is one process that we use to process graphs or other things like that. It's not common because our special situations in which we are going to speak about one graph processing. And also the real-time processing layer is one processing mechanism that we are going to use in one specific situation when we have processed information in the same time arrives to our system. We are going to describe later in this session how they are mapped to, for example, Hadoop tools, and we are going to say, for example, what can be one real-time processing engine. In this case, that the example is from batch processing engine, we are going to speak about batch processing engine. And the batch processing engine is the engine that helps us to process the information that needs to be processed in batches. Remember that batch processing have low latency, so the information is not available in the same moment we are making the process. Another thing we have here is the resource manager, because when we are always we are processing information in big data, we are going to use one resource manager. The resource manager is the one that decides what process it can be executed in one specific moment, the amount of memory that we need to use for that process, the amount of disk, and reserve the disk, reserve the memory. That is the function of the resource manager, and it's always needed in your process. You maybe don't have to deal with the resource manager, but in some moments it's needed to make configurations on that. And the coordination engine is the one that helps us to coordinate the information when we have a cluster. Remember one thing, I have said that when you are storing one file into the distributed file system, you don't need to decide which node are going to store the information. You just send the file to the distributed file system, and the distributed file system decides where to store the information. You can say, for example, each time I want to send one file, I need that file storage have the storage in four servers or 6 servers on just through 2 servers. You decide that, you configure that, but you don't say which servers are used for that storage. But the one that decides that is the coordination engine. When you send one file to the distributed file system, the one that decides which nodes are going to use is the coordination engine. That is why it's important. And we have here another, it looks like the previous one, but it's about real-time process. In the previous one, we have saw how the information is coming from the source. Store the information in the NoSQL databases and distributed databases, and it uses a batch processing engine. But in this one, we are using different mechanisms to move the information. This concept is very important because it's related with the previous one, where I showed that there are two types of different processing modes that can be batch or transactional. This real time can be transactional. The information can be, for example, coming from one sensor. You have, for example, sensors of temperature, and you have to make some sort of analysis, and you use the event data transfer engine. And the event data transfer engine sends the information to the in-memory storage device or in-memory database. And the processing engine, real-time processing engine takes information from the in-memory storage device and processes the information to the upper layers. That is the difference. The information moves faster than in the previous one. You can have the results of the analysis faster than in the previous one. And you can also have different sources of information. You can also information coming from one JSON message queue system, or you can have information coming from the sensor device. All the information can move to hard information. You can also, after the process has been done, you can store that information or persist information in a distributed file system or in a NoSQL database. In general, the process finishes with the real-time processing engine, and that is why you have to use that. Also, here is important the resource manager or the coordination engine, because the coordination engine helps to decide what information of what source can process first or what process can be done later. In the analysis layer, we have simply query engine and analytics engine. Here we have some differences because the query engine can be, for example, just one client that you use to make a sort of queries. You can make, for example, counts, simple counts, or try to bring down one data set that you need to make one simple analysis. And you can use, for example, a visualization tool to make that kind of analysis. But if you have made heavier processes where the processes are longer and maybe supervised or not supervised, you can use the analytics engine. And in the analytics engine, you can submit jobs and send those jobs to the systems, and let the system make the processes you need to bring out the results after that, for example. Also, in a big data project, we have a visualization layer. The visualization layer contains a visualization engine. Later in the practice, maybe we are going to differentiate and have clear what parts of the practice are of these layers. The visualization engine led us to see the information available in a browser, for example, in our Mozilla. You can use, for example, Mozilla in a web browser, for example. You don't need a specific client. You don't need to make a specific installation or a specific tool to make the queries. You maybe just need one web browser to make the visualization of the data, the results of the processes that you have done. This utilization layer, remember that we saw previously that the results are not always just a data set. When you have an analysis, you maybe decide that analysis will be some of these mechanisms that we have seen here. For example, you can decide that the information that you have processed is going to be a part of a relational database. So you can, for example, automate your process, make the analysis, and insert that information in a MySQL database, because you need to feed your CRM with the results of our analysis. Or you need to send information to FTP place, for example, or just download a file for one person. Also, you can have the possibility of show your results in one dashboard, maybe with graphics, KPIs, It's important to recognize that one dashboard is a tool that is used in the upper layers of one company to take decisions, to have a visual way to see how is going the business. And we can feed one dashboard with that information. Also, we can feed other enterprise application. For example, if you have a site when your users are buying things, you can, for example, feed that system with recommendations if you want, or your information can feed a service-oriented architecture in your company. Yes, all of these mechanisms that we can have here apply for how can be used the results of your analysis in a big data. So, in this moment, for example, you can think that you can work in a company making, for example, the process of acquisition data, or maybe work in the company in the area where the information is stored. No, you don't need to have all the qualifications to go to work in a company. Maybe you can just go to a company and work making the analysis. Because, for example, the data science work only in the analysis layer. They don't deal with acquisition of information. They don't deal with showing the information. There are specializations to show to the visualization layer. There are people working just in the way that you are going to visualize the information. We have here the layers that are cross-wide across all the layers. And the first one, we have the productivity portal. The productivity portal is a mechanism that we can use to manage all the platform. For example, we can use our web browser for making the acquisition of the information, for making the storage of information, to make the analysis. We are going to see one productivity portal later in this course, in the practices part, because it's easier to use the productivity portal just one place to move the information in all the layers that mean across each layer to move the data, to make the different analysis. It's better to use one place to make other things. And the cluster manager is a mechanism that maybe we don't use normally, but since then it manage, for example, the resource manager, manage, for example, the coordination engine, and here we can configure how they have to work. And the workflow engine, remember that I told you that maybe we need to automate the process. Yes, we can, for example, have processes that each night brings the information, for example, from Facebook, from Twitter, and we can have or automate that process using the workflow engine. And we have here the security engine. The security engine is the one that we use for make sure that there are no people that don't have permissions to have access to the data, for example, in the storage layer. How can assure that the people can access to data acquisition layer without permissions, because maybe we have sensitive information that we don't want that some people go enter that. And we have the governance layer. The governance layer the data governance manager is a mechanism that helps us to define things. For example, how long a data set will be alive in our storage. For example, we have data sets that have more than 7 years, and we don't want that information because we don't need that anymore. And you just use the data governance manager to say delete those data sets that are before from 7 years, or maybe compress the information that are from 3 years ago. That are the tasks we can use to find the importance of the data governance manager. In the last session, I know that you spoke about shared everything architecture and shared nothing architecture. For me, in this session, this slide is important because it's important to understand that in a shared nothing architecture, you can scale without any problem. For example, if you have simply 4 servers in one specific moment, and you need to process more information, you have more data to process, more data to store, you can increase the capabilities of the solution just adding servers. It doesn't matter if you have your infrastructure on premises in your company, or if you have in a cloud system. You can increase the capabilities of your system just by adding more servers. That is important. That is why it's important shared nothing architecture. And in this moment, we are going to start speaking about what is MapReduce. I have decided to put MapReduce in this moment. I know maybe you thought something about that in the last class. But MapReduce is not a tool, MapReduce is not a framework, it's a paradigm. It's a paradigm because remember that that in the shared everything architecture, you have your server, just one appliance of servers. That if you need, for example, more disk, you add more disk, but on the same appliance. If you need more memory, you add more memory, but in the same appliance. In the shared nothing architecture, you don't need one disk. You don't add a little bit more memory. You add servers. The paradigm for the developing, for the process of developing, is different. In the appliance, you need to program, for example, one Java application for one server. One or 3 maybe is the more. But here you have to make the development for several servers. And that is why MapReduce helps us. Because it's a different paradigm, a different thing on how program or make development for different machines. And then it's a distributed data processing framework.